Sometimes the universe throws a curveball, something so unexpected, so out of left field, that it forces us to rethink everything we thought we understood about the cosmos. These moments are rare, but when they happen, they challenge the very foundations of our knowledge and ignite a sense of wonder that reminds us how little we truly know. Today is one of those days, a day that will be remembered in the history of space exploration. NASA just dropped a bombshell announcement about a mysterious object called 3I Atlas, and the scientific community is buzzing with excitement and confusion. This isn't your average space rock. 3I Atlas is an interstellar visitor, a traveler from another star system, making a rare and fleeting appearance in our cosmic neighborhood. And it's doing something that has astronomers worldwide completely baffled, behaving in ways we've never seen before. The James Webb Space Telescope, our most advanced eye in the sky, captured detailed images of 3I Atlas, and what we saw was nothing short of astonishing. Its tail isn't just a random chaotic cloud of dust and gas like most comets. Instead, it appears structured, almost as if it's been engineered or shaped by some unknown process. The data suggests this isn't just a passive trail left behind as it speeds through space. There's something active, dynamic, and deeply mysterious about it, something that defies our current understanding of how these objects behave. To put this in perspective, 3I Atlas is only the third interstellar object we've ever confirmed passing through our solar system. First, there was Oumuamua, a cigar-shaped enigma that sparked endless debate. Then 2I Borisov, a comet-like wanderer with its own set of mysteries, both of which were strange and unique in their own ways, leaving scientists with more questions than answers. But 3I Atlas is different. It combines the bizarre, unexplained qualities of Oumuamua with the familiar appearance of a comet, yet it adds a twist that no one saw coming, a feature that sets it apart from anything we've ever observed. It's as if the universe just introduced a major plot twist in our ongoing cosmic story, reminding us that the script is far from finished and full of surprises. What does it all mean? Right now we're left with more questions than answers, standing on the edge of a new frontier in our understanding of the universe. That's the thrill of science, standing at the edge of the map, where the old explorers once wrote, "Here be dragons," marking the unknown with a sense of awe and anticipation. Or in this case, here be something with a weird, inexplicable tale, a cosmic riddle waiting to be solved. We're about to embark on a journey of discovery, venturing into uncharted territory with every new observation and theory. We'll follow the evidence wherever it leads, test our wildest ideas, and maybe, just maybe, expand our understanding of what's possible in this vast, mysterious cosmos. So buckle up and get ready. The ride is just getting started, and the universe is about to get even weirder. Let's focus on what's so strange and unprecedented about this discovery, something that has astronomers scratching their heads and rewriting what we thought we knew about comets. We're talking about the tale of 3I Atlas, a comet that's unlike anything we've ever observed before. The James Webb Space Telescope has captured images showing a tail that isn't the usual diffuse, wispy fan we expect from comets. Instead, it's a sharply focused, narrow beam of light and material, almost like a laser slicing through the darkness of space. It's as if some invisible force is actively shaping and directing the material, keeping it tightly confined and perfectly aligned, rather than letting it spread out chaotically. When scientists analyzed the tail using advanced spectroscopic tools, they found not just the usual suspects like water ice and carbon, but also unexpected ionized elements, superheated and moving at incredible speeds. The material in this tail is traveling much faster and is much hotter than what's seen in ordinary comet tails, suggesting a process far more energetic than simple solar heating. In fact, the way the tail streams out is eerily similar to the exhaust from a rocket nozzle, not the gentle release of gases from a melting ice ball drifting through space. Even more bizarre, the tail's brightness and shape have remained almost perfectly constant for weeks on end, completely unlike the unpredictable, chaotic outbursts and flickers we usually see from comets as they approach the sun. At the very core of the tail, there's a blue-white glow, a sign of extreme temperatures which then cools in a smooth, predictable gradient as you move farther from the nucleus, almost as if it's engineered. This thermal gradient is strikingly similar to what we see in rocket exhaust plumes, with intense heat at the source and a steady cooling along the length of the tail, something never before documented in a natural comet. In short, 3I Atlas's tail is stable, focused, and incredibly hot, defying every expectation and standing in stark contrast to the broad, dusty tails of normal comets. This is a cosmic mystery that challenges our understanding of how comets behave and what forces might be at work in the depths of space. It's a discovery that's forcing scientists to rethink what's possible out there, and it may even hint at new physics or phenomena we've yet to imagine. Before we dive into the strange behavior of 3I/Atlas, let's take a moment to understand what makes a typical comet tick. By looking at the usual anatomy of a comet, we can better appreciate just how unusual 3I/Atlas really is. A comet is often described as a dirty snowball, an ancient mixture of ice, rock and dust left over from the early days of our solar system. These cosmic wanderers drift silently through the vastness of space, sometimes for millions of years, until something nudges them closer to the sun. As a comet approaches the sun, the increase in temperature causes its icy core to sublimate, turning directly from solid to gas. This process creates a glowing cloud around the nucleus called a coma, a temporary, shimmering atmosphere that can grow to thousands of kilometers wide. Most comets develop not just one, but two distinct tails. The first is a dust tail, broad, curved, and pushed away from the sun by the pressure of sunlight. The second is an ion tail, which is straight, bluish, and formed as solar wind sweeps charged particles directly away from the sun. The dust tail is often the most visible part of a comet, sometimes stretching across the night sky and easily seen with the naked eye, trailing behind the comet's path. The ion tail, while fainter and more delicate, always points directly away from the sun, regardless of the comet's direction of travel due to the influence of the solar wind. Both tails are dynamic and unpredictable, constantly shifting in shape and brightness as the comet heats up and interacts with the sun's energy. This makes each comet's appearance unique and ever-changing. The entire process is messy, chaotic, and driven by the intense energy pouring out from the sun, making comets some of the most unpredictable objects in our solar system. This is the standard playbook for how comets behave, a set of rules astronomers have come to expect after decades of observation. But 3I/Atlas isn't following any of these familiar patterns. Instead, it's breaking the mold in ways that have left scientists puzzled. Its tail is single, sharply focused, and remarkably stable, defying the chaotic, dual-tailed nature we expect from comets. That's why astronomers around the world are so intrigued and eager to study it further. Clearly, something very different and mysterious is happening here, and it could change what we know about comets forever. With 3I/Atlas, we expected the classic two-tail structure. Instead, we see a single, powerful plume, combining features of both tails but behaving like neither. There's no distinct dust tail, even though plenty of material is being ejected. All the material is funneled into one focused beam, moving at hundreds of kilometers per second. The solar wind can't explain this. It's like a speedboat, not a sailboat. The tail's extreme heat is another red flag. Sublimation should cool the comet, not heat it up. The sun's energy at this distance isn't enough to create such high temperatures. Something inside or on 3I/Atlas must be generating massive energy. The evidence points away from the dirty snowball model. The focused tail, high velocity, and steady output all suggest something new. We're forced to consider possibilities that sound more like science fiction than astronomy. 3I/Atlas is rewriting the rules. Here's the boldest hypothesis. The tail of 3I/Atlas isn't a tail. It's an exhaust plume from a propulsion system. The focused cone, high-velocity particles, and extreme temperatures all look like an engine in action. Not a chemical rocket, but maybe an advanced ion drive or plasma thruster, using electromagnetic fields to accelerate ions. This would create a hot, blue, focused exhaust, just like what we see. The stability of the plume fits too. A machine would run steadily, unlike a sputtering comet. It suggests purpose, control, and design. Of course, this is just a hypothesis, an extraordinary claim needing extraordinary evidence. But right now, it fits the data better than any natural explanation. Suggesting we're seeing alien technology is a monumental leap. But the physics of 3I/Atlas is pushing us to consider it. We're not chasing aliens, we're following the evidence. And the evidence is stranger than fiction. The universe may be telling us something big. The astronomical community is buzzing with excitement and skepticism. Dr. Amina Khan from ESA says, "We've tried every conventional model, none fit, we're in uncharted territory." Some, like Dr. Kenji Tanaka of JAXA, urge caution. Maybe it's a new, unknown type of natural object with exotic materials. we must exhaust all natural explanations first. Others, like Professor Avi Loeb, are open to the technological idea. The universe is vast, to assume we're alone is arrogant. He argues the engine hypothesis is the simplest explanation for what we see. The consensus? We need more data. Every telescope is now pointed at 3I Atlas, gathering spectroscopic readings, thermal images, and trajectory data. The debate is fierce, but healthy. This is science at its best, puzzling observations, competing ideas, and a race for evidence. No one knows the answer yet, but everyone agrees. 3. I Atlas is something special. Before we leap to alien engines, we have to consider every natural explanation. Maybe 3I Atlas has a unique spin and a single vent, creating a constant geyser effect. Perhaps radioactive decay deep inside is heating the material, or a powerful magnetic field is shaping the plume. These ideas are plausible but require a rare combination of factors. Science prefers explanations that don't rely on cosmic coincidences. The Copernican principle says we shouldn't assume we're seeing something unique. Ironically, the engine hypothesis, while wild, explains all the features with one device. We're left with a choice, a cosmic 1 in a billion, or a purposeful machine. Either way, it's a mystery worth chasing. Let's not forget Oumuamua, our first interstellar visitor. It was weird too. It accelerated away from the sun with no visible tail, sparking talk of solar sails and alien tech. Then 2I Borisov arrived, acting like a normal comet, a relief to astronomers. Now, 3I Atlas is even stranger, a focused, hot plume, possibly self-propelled. 2 out of 3 interstellar objects are breaking the rules. This might not be a fluke, it could be a pattern. Maybe we're finally seeing the high-speed traffic of the galaxy, thanks to new telescopes scanning the sky. We missed these objects before because we weren't looking. Now we're finding the universe is far more interesting than we imagined. Are we glimpsing a galactic community at work? The more we look, the weirder it gets, and that's just the beginning. The discovery of 3I Atlas marks a new chapter in our cosmic exploration. Whether it's a natural wonder or alien tech, it's already changed the game. If it's natural, we found a new class of celestial object. Time to rewrite the textbooks. If it's technology, it's the most profound discovery in human history. Proof we're not alone. Either way, our understanding of the universe will never be the same. For now, we stay patient, curious, and rigorous. We observe, hypothesize, and test. The story of 3I Atlas is still being written, and we're lucky to witness it. Whatever the answer, it's a win for humanity. The universe just got a whole lot more interesting.